Hi, my name is Jason. This is my assignment 2 for Comp 3132, the Applied Machine Learning, so I'm going to take you through it. So here we have just these simple prompts of finding the CSV file. So that's CSV file. So essentially the first part is about, so we're going to mount it from a Google Drive, which I've done already. So we're going to rename the path to file name, and we're going to use pandas to read the file. So I can start from here. We can go here. And here we're using the head to essentially show the first 5 rows. So that's that. Here we're going to convert the last column strings to the integers. So we're going to use the mapping to have this dictionary and assign the specific string to the value that we want to set, 0, 1, and 2. Of course, we have the head again just to show that it worked out. So we go back. We have Setosa for the species here, and here we have 0 based off the one we want to convert it to. Here we're going to use the ilag to show all rows of the first 4 columns, and we're going to assign it to x. Same thing with y, but we're going to only assign y the last column, the one we just changed. So that went through. Here we're going to do our train test split. So we're going to import that from sklearn, and here we're going to train test split our data into 20%, which we got from here, and a random state, which we got from here. And we're going to check the first 5 rows again of each. So we're going to go through them. We're going to apply the head to each of them, which is x train, x test, y train, and y test. That should show that it's working. In here, it's supposed to get 120 and 30 to make sure. And that's what I've gotten, 120 and 30. So we're going to keep it moving. Here, we're going to convert the categorical values to the one-hot encoded values. And we're going to use the get dummies from Panda. Here we're creating the model. So essentially we're going to follow these instructions of the sequential model, 3 dense layers, with 100 units, and this activation function. So that's what I've done here using the imported from TensorFlow. And here's a model with the sequential. The input is to essentially shape the data of how we want it to be. Here, the dense with the units and the function that we're going to use. Run that. Here we're going to compile it using this optimizer, using this loss, using the categorical because we're dealing with the categorical values, and we're going to measure the accuracy. Here we're going to train our model. You can see with the good accuracy right here, and we're going to test it on new data. As you can see, it's basically the same. So we know that the model is pretty damn accurate. So here, essentially, we're going to do the same thing for like number 6. That's what we've done. So here we have the other model. Of course, the same song and dance, but we're going to use 10 units, but the same activation function. Here we're going to compile it using the same parameters that we used before. Here we're going to train this model. We get about 44%, 45% accuracy. And if we train it on others, we get about half. So it's essentially the same, even though the accuracy is obviously not what we want. It's not up to par. So essentially, the number of layers and units can impact the accuracy because increasing the layers and units will allow the model to learn more complicated and complex patterns, and it could increase the accuracy as what we did before. But too much of it can also cause it to overfit with unseen data. And do we suffer from it? Not necessarily, but with the right steps, we can balance it out. So essentially, those steps are like reducing the number of layers or increasing training data, etc., etc. But we can detect overfitting based off the gap between the training data and the testing data. So in terms of the accuracy, so if the training data has higher accuracy than the testing, then that could be a sign of overfitting. So we're going to change some of these parameters just to show how it works and go through it. So we got the accuracy. This is essentially the default that we're going to use. you know, the 0.5 from the model that we trained before. Here we're changing the optimizer, so if we run that, so we're changing it to Atom. We change that, we get a 0.7 essentially. So changing the optimizers can increase the accuracy. So we're gonna go to the layers. We're going to run that. Also, I decided to do it this way because I thought it was easier to, you know, show how each of the changes, you know, just have the default and we're just going through the changes. So we have the layers here, 0.3. So essentially that, you know, that's lower than our default because we're actually increasing the layers, but we don't have the training data. So this essentially is a sign of overfitting. And we have the hidden units here. We're going to run that. So we have 0.8, which is actually better than our default. So essentially this is showing how it can learn complex patterns and also increase, but yeah. So here we have the changing of the epoch. So before we had 4, and now we're changing it to 10, and as you can see we got 0.86. So essentially changing the epoch is just letting the model learn more of the data. And so learning more of the data means better accuracy. So of course this is the highest that we've gotten. And changing the batch size, of course this is way lower than what we initially gotten because the model hasn't or the model isn't able to necessarily read and train as properly as we want it to be because the batch size it's using is lower than the original. So that is my assignment and appreciate you for listening.